I'm going to leave it here. All right, and so for my second question here, it wants to write the electron configuration for a few cations and a few anions. Specifically, these are quite deep in the table here. So strontium is over here. Cesium plus is here. Indium is over here. And lead is down here. Okay, so for when we're writing the electron configuration, I always find it's easiest to just run along the table. And so remember, first of all, that helium should really be here as far as the blocks go. So we have our S block, our P block, our D block, and our F block. And remember that the F block really goes in here. So these guys go in here. All right. So for strontium, we have 1s2, and then nothing, and then 2s2, and then 2p6, and then 3s2, and then 3p6, and then 4s2, and then for the D block, we hold 10, but it starts at 3D, and so there's 10, and then 4p6, and then we get up to strontium, so we've got 5s2. All right, so that's our electron configuration for strontium. Now if we want to do 2+, well, we just remove 2 electrons. And we always remove the outer shell ones, so then that's our strontium 2+. Now repeating this for indium, or cesium, sorry. So again, we've got our 1s2, so cesium's down here, so it's pretty much got the exact same configuration of strontium. 2s2, 2p6, 3s2, or at least it has all the beginnings of strontium, I should say. It's a whole nother shell down. And then 5s2, and then now we go to 4d, so 4d10, and then 5p6, sorry. Yep. And then 6s1. And now again we want to get the positive, so we just remove this outer electron. And now for indium, well, indium is over here, so it is strontium plus the D electrons. So all the way up to here, 5s2, 4d10, 5p1. So we want indium plus, so we just remove one of the outer electrons, and there we go. And then to get lead, we continue down the line. So 1s2, 2s2, 2p6, 3s2. And we keep going pretty much up to where cesium is, and then go a bit further. Okay, so then 6s2, and now the F block comes in, and like the D block, it doesn't start at the same number, but for the F block it actually starts 2 less, so it's going to be 4F, and there's, if you count them, 14. So there's 14 there. And then the D block, so that's 5d10, and then the P block, 6p2. And then we want 2 plus, so we just cut out 2 electrons. And so then there is our electron configuration for lead 2 plus. Now for the anions, actually for the anions, I'm just going to erase this. So there's all our cations, and like I said, we just count across. Alright, and I'm just going to erase all this. And so now the anions it wants are just phosphorus, sulfur, and bromine. So for phosphorus, again, remember that helium should really be over here. So we have 1s2, 2s2, 2p6, 3s2, and 3p3. Now to get the 3 minus, we need to add 3 electrons, not take away 3 electrons. So instead of 3, we now have 6. So it actually has the same, my periodic table has an H for argon. Has the same configuration as argon. Okay. So then the next one is S. So for sulfur, it's pretty much right next to phosphorus. So it's 1s2, 2s2, 2p6, 3s2, and then 3p, counting right up to where sulfur is, 4. Now to get 2 minus, we add 2 electrons. And so it's the exact same configuration. And now for bromine, we've got our 1s2, 2s2, 2p6, 3s2, 3p6, so all the way across, and then 4s2, and 3d10, and then 4p5. And then to get the minus, we just add 1 electron. So instead of 5, this becomes 6. Okay, and so there's our anion electron configurations. Okay, so here's the solution. So the f orbitals actually don't have 16 electrons, they can all have 14. You can just get it by just counting. And then yes, we can write it as in condensed. I find it much easier just to count across, which is basically what this is showing. If we look back or think back, so these are the configurations we have for our strontium, our cesium, and our indium. The lead here is missing the F block, so that's not so great. But then for phosphorus, sulfur, and bromine, this looks good. So it's really just the lead is missing its F block. But I would say the solution is largely correct. F block can only hold 14, not 16 electrons. And the lead configuration is missing F block electrons. But it's, I would say, basically correct.